There is a misconception sitting quietly at the center of our civilization's grandest ambitions, a psychological error so deeply woven into the way we imagine our future that almost no one stops to examine it. We have spent decades perfecting the narrative of humanity as an eventual intergalactic species. We picture our descendants mastering fusion drives, bending space-time with exotic propulsion, threading through the arms of the Milky Way like ancient maritime explorers threading through archipelagos, and then one glorious day simply pointing the nose of a ship toward a distant smear of light in the sky and flying outward without limit. It is a beautiful picture. It is also, from the perspective of the laws of physics, a profound illusion. The error begins not with engineering but with geometry. We instinctively model the cosmos the way a child models a large house. Master the rooms inside, and the front door to the outside world is merely the next natural step. But the universe is not a house with a front door. It is a structure whose architecture actively forbids certain exits, not through technological limitation, not through lack of willpower or resources, but through the fundamental mathematical behavior of space-time itself. To understand why, we need to begin not with distant galaxies, but with where we actually live. The Milky Way is not an island. This is the first critical piece of geometry most people never fully absorb. Our galaxy sits inside a gravitationally bound collection of roughly 80 neighboring galaxies called the localgroup. The two dominant members are the Milky Way and the Andromeda galaxy, two colossal spiral structures whose combined gravitational influence reaches outward across more than 10 million light-years, pulling every smaller satellite galaxy, every dwarf companion, every wandering stellar stream back into a shared gravitational basin. This is not a loose association. This is a deep physical well, a curved depression in the fabric of space-time that holds its members the way a bowl holds water, shaping the trajectories of everything inside it. Now here is where the mathematics becomes genuinely sobering. To leave a gravitational well, you must achieve escape velocity, the minimum speed required to climb out of the well's depth without any additional thrust. For a rocket leaving Earth's surface, that number is roughly 11 kilometers per second. For an object attempting to leave the gravitational basin of the entire local group, the calculation transforms into something of a completely different character. The combined mass of the Milky Way and Andromeda alone reaches into the hundreds of billions of solar masses, include the vast distribution of dark matter halos surrounding both galaxies, halos that extend far beyond the visible stellar disk, and the gravitational influence of the local group becomes staggering. Numerical estimates for the escape velocity from the local group's gravitational core place the threshold at velocities approaching a significant fraction of the speed of light, not a few kilometers per second, not a few hundred kilometers per second. We are speaking of velocities in the range of hundreds of kilometers per second at minimum, even from the outer edges, with the energy requirements scaling in a way that quickly becomes physically incompatible with the structural integrity of any matter-based machine we can conceive. Think carefully about what this means, not what it means technologically, what it means physically. The energy required to accelerate a ship of any meaningful mass to these velocities and sustain that acceleration against the gravitational gradient of the local group approaches the energy scales associated with stellar processes, and this is before we have left the building, before we have taken a single step into true intergalactic space. Consider an analogy that maps the situation more precisely onto biological intuition. Imagine a highly intelligent creature living at the bottom of the deepest ocean trench on this planet, inside the hollow ruins of an enormous sunken ship. This creature is brilliant. Over many generations, it has mapped every corridor, every flooded chamber, every rusted stairwell. It navigates its environment with perfect fluency, and it has begun to theorize. It can see, through the broken portholes, faint traces of distant light far above. It reasons that one day, once it has truly mastered movement within the ship, it will simply swim upward through a broken window, rise through the water, and emerge into that world of light. The creature does not appreciate two physical boundaries that are absolute. First, the crushing pressure of the deep ocean is precisely what holds the ship's structure in a recognizable form. The ship and the creature's entire civilization exist because of the containment of that pressure. Second, and more fundamentally, above the ocean's surface there is no water. The medium that allows the creature to breathe, to move, to exist in any biological sense simply ends. The border of the ship is not a challenge to be overcome with better fins or stronger muscles. It is a thermodynamic and biological absolute. The creature's entire framework for understanding movement and survival becomes physically incoherent the moment it crosses that threshold. The intergalactic medium is the universe's version of that missing water. Suppose for a moment that an extraordinarily advanced civilization solved the energy problem. Suppose they built a ship capable of achieving the velocities necessary to climb out of the local group's gravitational basin. What greets them in true intergalactic space is not the peaceful void of science fiction. It is a plasma environment of remarkable hostility. The space between galaxy clusters is not empty. It is threaded with what astrophysicists call the warm-hot intergalactic medium, a diffuse network of ionized gas, filamentary structures left over from the large-scale formation of cosmic structure, heated to temperatures ranging from 100,000 to 10 million Kelvin by the gravitational processes that built the universe's architecture. The density is extraordinarily low, far lower than the best vacuum achievable in any terrestrial laboratory. But density is not the relevant variable when you introduce relativistic velocity. At near light speed, even a handful of particles per cubic meter transforms into something terrifying. A ship moving at a substantial fraction of the speed of light through the warm, hot intergalactic medium does not gently push aside sparse plasma. The mathematics of relativistic particle interaction dictates that from the reference frame of the ship, the sparse ions of the intergalactic medium are impacting the hull with energies comparable to high-energy cosmic ray particles. Each collision generates radiation. Each layer of hull material absorbs energy, heats, ionizes, and is progressively removed. The physics here is not speculative. It is the same physics that governs particle accelerators and cosmic ray detectors. The diffuse plasma of intergalactic space encountered at relativistic velocities functions as a continuous radiation beam, patiently and precisely stripping the atomic structure of the ship layer by layer across the millions of light years of transit. There is no hull material that escapes this process. The stripping is cumulative, relentless, and governed by equations that do not negotiate. And yet even this barrier, as severe as it is, does not represent the final and most absolute boundary. That distinction belongs to the geometry of space-time itself, specifically to the phenomenon we call dark energy. Within the local group, gravity dominates. The mutual gravitational attraction of the Milky Way, Andromeda, and their companions overcomes the background expansion of the universe. This is why the local group is bound, why Andromeda is actually moving toward the Milky Way rather than away from it, why the members of our cluster do not drift apart over cosmic time. Gravity wins locally, but locally is the critical word. Beyond the gravitational reach of our cluster, the universe is doing something geometrically radical. Space-time itself is expanding, and that expansion is accelerating. Dark energy, the name we give to the physical mechanism driving this acceleration, acts as a property of space itself. Every cubic meter of space contains a small but non-zero energy density associated with dark energy, and this energy density causes space to expand at an accelerating rate. The consequence for cosmological distances is that the space separating our local group from other galaxy clusters is not simply large. It is growing larger at a rate that now exceeds the speed of light. This requires careful unpacking because it is frequently misunderstood. Nothing is moving through space faster than light. Instead, space itself is being created between distant regions at a rate that causes those regions to recede from each other faster than light could travel between them. The distinction matters because it closes a conceptual loophole. You cannot simply accelerate your ship harder to compensate. There is no speed, no thrust, no conceivable propulsion mechanism that allows you to cover ground faster than new ground is being created beneath you. The distant galaxy clusters are not running away from us. They are being carried away by the generation of fresh space-time, and the rate of that generation is increasing. The observable universe has a horizon, a distance beyond which light emitted today will never reach us because the expansion of space will carry those sources beyond any causal contact with our location. But this horizon also works in reverse. Light and ships and signals originating from our location will never reach galaxy clusters beyond a certain distance because the expanding geometry of space will prevent them from closing the gap. This is not a horizon in the sense of a visible boundary one can approach and cross. It is a mathematical feature of the universe's geometry, a surface embedded in the structure of spacetime that divides regions which can exchange information and matter from regions which cannot, permanently and increasingly. What emerges from layering these three barriers together is a picture of the universe as a system that fundamentally organizes matter into quarantined volumes. Gravitational wells create local clusters. The thermal violence of the intergalactic medium punishes any matter moving through it at the velocities needed to escape those wells, and the accelerating metric of spacetime seals the outer boundary with an absolute that no propulsion system operating within the laws of physics can address. The universe does not present these barriers as engineering challenges awaiting clever solutions. It presents them as consequences of its own foundational structure. There is something worth sitting with in the sheer scale of what is still available within our quarantine. The local group spans roughly 10 million light-years. The Milky Way alone contains somewhere between 200 billion and 400 billion stars. The number of planetary systems within our gravitationally accessible volume is so large that the mind genuinely cannot form a proportionate image of it. If our civilization survives for millions of years and develops propulsion systems capable of crossing the Milky Way in reasonable time frames, the accessible volume of space within our local group represents a canvas of exploration so vast that it functionally approximates the infinite for any practical purpose we can currently conceive. But that canvas has edges, and those edges are not the edges of our current technology. They are the edges of what the universe's own architecture permits. The picture of humanity, someday simply flying outward galaxy by galaxy, stepping across the cosmos like stones across a stream, belongs to a misunderstanding of the physics of the space between those stones. The stones are gravitationally bound islands in a sea whose geometry is actively expanding. The sea between them is a relativistic furnace for anything attempting to cross it at survivable velocities. And the expansion of that sea is accelerating past the speed of light, generating a cosmic horizon that moves further from us with every passing moment, not because we are falling behind, but because the universe is manufacturing new distance faster than physics allows anything to travel. We are not simply far from other galaxy clusters. We are, in the most geometrically precise and physically grounded sense of the phrase, permanently separated from them. The local group is our universe, not as a poetic metaphor, as a statement about the causal structure of space-time. The door to the wider cosmos is not locked for lack of a key. It is locked because the lock is made of the same physics that makes the door possible in the first place. And that is not a limitation of human ambition. It is one of the most profound and quietly astonishing facts the universe has ever offered about its own architecture.